I am going to write an equation and then you tell me whether it is a quadratic equation or not. Okay? So x squared plus 9 is equal to 0. Is that a quadratic equation? Yes or no?
No.
Okay, somebody suggested no. No. Okay, now let me rewrite this equation and then you tell me. You tell me. I'm going to rewrite the equation. I'm going to write x squared plus 0x plus 9 equal to 0. Is this a quadratic equation or not?
Yes.
The person who said yes, did you say no before?
No.
Okay, so now you're saying that those who said no before, do you look at the second one and see, is it the same thing or different? Muhammad, go, you said no before. Are these two equations the same thing or are they different?
They're different.
Okay, what's the difference? What makes it different?
0x.
Okay, so 0 times, let me ask you this. 0 times 100 is what?
0.
Okay, so 0 times x is also 0. And then 0 plus 9 is what? 9. So what that means is the first one and the second one are the same. Am I making sense now?
Yeah.
All right, so, and then since you agree that the second one is quadratic, it means the first one is also quadratic. All right, so now the question is, let's consider the first one. Let's consider the first one only. Let's consider the first one. How do we solve for x?
You subtract 9 on both sides.
Okay, hold on right there. So you say we should do x squared plus 9 minus 9 equal to 0 minus 9. And then that's going to give us x squared equal to negative 9. Is that correct?
Yes.
And then what's next?
You square root both sides.
Okay, we square root both sides. So what's your first name?
Fatima.
Fatima. Okay, so I'm hearing you say we should do x squared equal to square root of negative 9. Okay, so now how about the left side? What shall it give us? What is it going to give us?
X.
X. And then how about the right side?
9. No, wait.
Is
3
square root?
and an imaginary number? I don't know.
Plus or minus? Okay, so now look, use your calculator. Use your calculator. You can use your cell phone calculator.
Is it 3i?
Oh yeah.
I didn't say Google it. I said use your cell phone calculator. What did it give you?
Error.
Okay, I'm trying to hold on. I'm trying to pull up a calculator everyone can see. Okay, can you all see this calculator?
Yes.
All right, so now we are trying to deal with negative 9, right? So let's go to square root. Square root, second function, square root, and then we have negative 9. And then we move out of the square root sign. And then we hit enter. Boom. Error. No real answer. You see? So what this thing is telling us is that if we try to do the square root of every negative number, it gives us an error. It means there is no solution. It means the problem cannot be solved. You see? So there is no real value. There is no real value for square root of negative 9. But if we try to do the same thing with positive 9, let's try to do the same thing with positive 9 and see. Square root, and then we just type 9 only. And then we move out of the square root sign and we hit enter. Boom. It gives us what?
3.
All right. So now here's how to deal with negative numbers. So let me get back to the screen where we were. So now, because we had, so in this particular case, if we just do square root of negative 9, it's going to give us an error. So here's what you do. You can expand this to say square root of 9 multiplied by square root of negative 1. And you can do square root of 9 to be 3, but you're still left with square root of negative 1. So now, square root of negative 1 has a very, very special case in mathematics, and it has a special name, and that name is called imaginary. And any number that has an imaginary is called a complex number. So square root of negative 1 is imaginary. And any number that has imaginary is called complex number. So in this case, the imaginary is also say square root of -1 is I. So in this case, we're having x is equal to plus or minus 3i. Somebody said it before. The reason why I didn't acknowledge it initially was because if you press your calculator, it might not really give you 3i. It might not really give you 3i. So I just wanted to make sure that everybody is understands how that I came about. Any questions so far?
No.
Okay, now the problem now becomes, how do we solve quadratic equations that results into imaginary numbers? How do we solve it? Or how do we manipulate imaginary numbers or complex numbers? How do we manipulate complex numbers? So that's the subtopic.
Mr. Ukebu, what was the topic again?
Complex number. Original topic is quadratic equation and complex number. Now we dealt with quadratic equation a little bit. So subtopic, second topic B is complex number. So now, since we now know how to deal with imaginary numbers, so let's try to solve different examples of imaginary numbers, or how imaginary numbers can be represented generally. Or if you like, call it complex numbers. So now what you must know is that I is square root of -1. On the other hand, I squared is equal to -1. I squared means you're just doing this into 2 times. So I squared is -1. Okay, so now for a number to be said to be an imaginary number or complex number, there has to be a way that number has to be represented. So, for example, the general format that you use in writing imaginary number is you write it in this form: a plus bi, where a is a real number and also b is a real number. And both A and B are non-zero. They are not zero. They are real numbers. It can be 1, 2, 3. It can be negative. It can be positive. They are real numbers, so they are not zero. Okay? Because if A is 0 and B is 0, then you don't have a number. So this is the general, you can call this general notation of complex numbers. General notation of a complex number. Okay, so now let's give an example of this. A complex number, look at this one. This can actually be, this one can actually be, it can actually be 0 plus 3i and 0 minus 3i. So which is still the same format, plus or minus. So now there are actually 3, 4, 5 things you can do with complex numbers. So you can add complex numbers. So let's try to add complex numbers. Adding complex numbers. Okay, so this is a subtopic, if you will. So now let's give different examples. So somebody can say, add the complex number, this and this. Question. Add complex numbers, and then the complex numbers I want us to add will be -6 plus 4i and -6 and plus 4i and 4 minus 7i. Add the complex number. Give it a try. Now, can somebody help us to see how we can add this complex number?
You're gonna what's it, combine like terms, something like that?
Okay, combine like terms. So what are the like terms?
The I and the normal numbers.
In order to add this, we can do -6 plus 4 plus 4i minus 7i. And what does that give us? I'm
Two.
sorry, negative 6 plus 4 is
It's -2.
negative 2. And then how about 4i minus 3 minus 7i?
Plus 11i.
Plus and minus.
4i minus 7i.
Yes.
3i.
Yeah.
Oh yeah, it's not negative. It's not
Negative
okay.
3i. Negative 3i. So that's the solution. When we add this, if we add this, it gives us negative 2, negative 3i. Now, how about if we subtract this? So subtract, instead of add now, perform the subtraction. Subtract, negative 6 plus 4i and 4 minus 7i. So instead of performing addition, then perform subtraction. Somebody said that he or she is confused. So what's the confusion? Let me know. At what point are you confused? I mean, somebody said I'm confused, so I just want to know the point so that I can address it now before going to the next step. Okay, so now everybody try this second one. Do the subtraction instead of addition.
You say subtract -6 plus 4i and 4 minus 7.
Yes, so instead of performing addition, in the first case we did addition. So this time around we are going to do subtraction. So we are either subtracting negative 6 plus 4i from 4 minus 7i, or we are subtracting 4 minus 7i from negative 6 plus 4i. So we just have to perform one of the operations. Instead of I, we're doing subtraction.
No, I'm confused as to why the word subtract is there, and then we're subtracting one problem from another.
You are subtracting one expression from the other. You're just performing subtraction operation. That's what I'm trying to explain. The question can be, perform addition or subtraction operation on the complex number. That's typically how they ask, put in the question.
Can you hear me?
Yes, I can hear you. Go. Okay, here's what he said. Here's what he said. If I were you, here's what I'm going to do. Solution. I am going to borrow his idea, but I will just write it in a different way. I will just write negative 6 plus 4i minus bracket 4 minus 7i. I will first of all write it this way. And then I will open the parentheses. So when you open the parentheses, you are going to have negative 4. Negative times negative is what? Positive. So you have positive 7i. And then you still retain the other side, which is negative 6 plus 4i. And then you now combine like terms. So what are the like terms now? Yeah, so you have negative 6, negative 4 plus 4i plus 7i.
So negative 10.
Yes, so negative 10 plus 11i. And that's the solution when you perform subtraction. Okay, so how about multiplication? So question is going to be multiply. I'm going to use the same number. Negative 6 plus 4i and 4 minus 7i. So how do you perform the multiplication? I'll give you 1 minute to think about it. Okay, somebody said distributive property. Sounds like a good idea. Solution, for you to do distributive property, you can just write negative 6 plus 4i bracket 4 minus 7i. So now somebody has given us a good hint. So I'm going to give you 2 minutes to complete it. Use distributive property. I'm going to give you 2 minutes. Okay, all right, Adam. Let's see. Give us a hint.
First, we should multiply the negative 6 times the 4 and the negative 7i.
Okay, so you are using distributive property, right?
Mm-hmm.
Okay, so he said we should do negative 6 times 4 will give us what?
Negative 24.
Negative 24, and
then you multiply negative 6 times negative 7i, which would be negative 42i.
Negative times negative is positive.
I mean positive 42i.
So it should be positive 42i.
My bad.
And yes, yeah, no problem. Yeah, then continue.
And ew, what the hell? So then you multiply the 4i times the 4 and the negative 7i. So that would be 6 plus 16i.
Okay, plus 16
I.
I.
And then you multiply it, and then that'll be negative 28i squared.
Okay, so then we are going to have, because positive times negative is negative, so we have negative 28I squared. Okay, so now, yeah, so now let's go. Let's see. 42I plus 16I gives us what?
58i.
Okay, 58I. Then we still have negative 24 plus, and then we have negative 28. Remember that we earlier said that negative, no, we earlier said that
Negative
I
1
squared is negative 1,
equals
right? So
yes.
just put negative 1 here. And what does that give you?
It gives you
4.
plus 20.
Positive 28.
Oh.
Negative 24 plus 58I.
You combine like terms, then it's 4 plus 58i.
Yes, so you have 4 plus 58I. And that's a complex number of this form. Good job. Yes. So now let's do division. Let's do division as well. Let's do division. So we've done addition, we've done subtraction, we have done multiplication. So let's do division. We are going to use the same number and perform a division operation. So the question becomes divide negative 6 plus 4I by 4 minus 7I. So I'm going to give everybody 2 minutes to think about this and come up with a solution. Okay, so now let's go. What's your idea? What do you think we should do first?
I mean, I divided 4 into negative 6. And I divided, what was it called? Negative 7i into positive 4i.
Okay, that's a good idea, but it's not going to work. So let's write it out first. Let's write it out. Let's write out negative 6 plus 4i divided by negative 6 plus 4i divided by 4 minus 7i. Okay, what you do in this type of situation, you cannot really perform the division the way Adam suggested, because it's not going to work. But what you do is what is called, you use what is called conjugate. So you find out the conjugate is the word I'm trying to say is conjugate. You use conjugate of denominator. Conjugate of denominator. So now, for example, the conjugate of denominator is going to be, I would say the conjugate of 4 minus 7i is 4 plus 7i. Okay? So now, once you determine the conjugate, so you multiply the numerator and denominator by the conjugate. So you do negative 6 plus 4i multiplied by 4 plus 7i divided by 4 minus 7i multiplied by 4 plus 7i. So that's how you set it up. You can see 4 plus 7i can cross out 4 plus 7i, but that's not the purpose. The purpose is to help you make sure that the denominator has no complex number in it, because that's what the denominator is going to be. Once you multiply the conjugate of a number by the number by its conjugate. What do you think we should do? Yes, use distributive property. So everybody, you are going to finish up this problem by yourself, but use distributive property to finish it up.